So today I want to focus a little bit more on how you can write Eiffel programs. I'm going to explain different parts of the syntax which you might run into trouble with, especially for lab number 1 on Wednesday. I'm still writing up, but it's going to be a very interesting lab for you. You're going to write contracts, mathematical contracts. So today I will review some mathematical concept with you, and also to go over with you very quickly some certain syntax in Eiffel. So we're going to do also some program in Eiffel Studio. Conceptually today is not that heavy, but try to pay attention. Okay, let me just switch back and forth between slides and Eiffel Studio. Let's go to Eiffel Studio. Let's go to slides very quickly. So starting from now, we are not going to deal with Java anymore, because somehow we talk about in the previous 2 lectures that Java is not that convenient for us to do design by contract. If you're still not convinced, feel free to talk to me in person. I will explain to you again the ideas, okay? So now we're gonna do it in Eiffel. So now for Eiffel there, we have to pay attention to the syntax. The syntax, I would say, the majority of the syntax is very similar to what you have to write in Java, but certain parts that kind of seem peculiar. Okay, so that's what you have. I'm gonna type it out in just a moment. But what I want to do is to show you some, give you some big picture idea about what you should write in terms of Eiffel classes. First of all, when you start writing a class, it has to be all capitals separated by underscore. And then it is really important that, unlike Java, in Java the constructor name is just the same as a class name. In Eiffel, it gives you complete freedom as to what kind of name you like. The catch is you have to explicitly declare which commands. So first of all, let me just tell you something here. I'm going to use the Eiffel terminology a little bit more. So what we used to say method over here in Java, right? In Java, you got 2 kinds of method. It can be mutator or it can be accessor. That's in Java. But now in Eiffel, I'm going to say that a little bit differently. You can very easily just get used to it. Eiffel there, mutator means you're going to change something, which means you're going to command certain changes. So it's called command. So whenever I talk about command in class, that means mutator. And also for accessor, that means you're trying to ask certain questions about the current state of your objects. So it's called query. And attributes are still attributes, no difference. Attributes the same. Okay, command versus query. Okay, let me just go back. So now for your constructor there, the constructor presumably should be a command. So you choose 1 or more commands and you put it under the create clause over here, and then you say that I'm going to use these commands for constructors. I'm going to demonstrate it to you in Eiffel Studio. And then there's a keyword called feature in Eiffel Studio. You can think of it, it's like a tag for you to organize the structure of your Java class, Eiffel class. Okay? You can have as many features as you like, but I would recommend one very straightforward way of doing that is to have maybe 3 feature sections. The first one for attributes, the second one for commands, the third one for queries. And you can also declare invariants at the end for class invariants. So that's about the class. Okay? So today for the syntax, I'm going to go maybe not so slow, but if you really want me to explain more, feel free to raise your hand. Otherwise, I'll assume everybody is okay. Okay? After that, you can read the description here. And I'm going to show you there is a very useful feature option in Eiffel Studio called groups, where you can see the package, like a package explorer in Eclipse. Okay, that's about a class. What about a feature? Oh, by the way, one more thing to mention. In Eiffel, we also got another term that's very general. Attributes together with command and query, you can say they are all features. Okay, so when I say a feature, it can be an attribute, can be a command, can be a query. Okay? All right. So now, let's say we have some command. When you say you're defining some command, like a mutator, you simply don't return anything. Okay, just the name of the command. Let's say there's no parameter. I'll talk about how you can declare a parameter in just a moment. So here's the general structure. First of all, require. All of you have seen require, ensure, and do these keywords in lab number 0. Let's explain why, what they really mean. Require means the condition, which is Boolean, that you require any clients of this particular feature to satisfy, which is precondition. Okay? Require is for you to specify preconditions. So there's no exception handling anymore, just require. Under the require, you can just put as many Boolean conditions as you like. I will illustrate to you in just a moment. And unlike Java, if you want to declare local variables, you have to centralize them into one single place right in the beginning. Of course, anytime when you're developing your code, if you want a new local variable, just go back to the local and then add more. Okay? That's just one single section. You cannot declare local variable in the middle of the code. And now what goes under do is the implementation. So that's something that's hidden from the clients. And you got ensure. What's ensure? Ensure is also some Boolean condition which the supplier ensures that will be satisfied upon the termination of the feature. And what's that? Post condition. Okay? So now, the most important two keywords you should know now. Require means precondition for this particular command. And ensure also means the post condition for this particular command. Okay? And also for query as well. We can see examples. Okay, precondition. And you have seen also example in the lab. Okay, I'm gonna make that explicit to you. So you may leave out the require and ensure if you like, but that means that you should really know what they really mean. Okay. Let's say I have a feature over here, let's say command. I'll say some command. I say do something over here and end. That would be the simplest command you can write. You can see there's no require, there's no ensure. However, this is a very bad feature because you are not trying to write any contract. But let's see what that really means. This really means the following. Some command, when you have no require, it's like anything will be okay. It's like require, and as I said before, require and ensure they take a Boolean expression. In this case, would that be, what kind of special value do we have? True, exactly. So what does true mean? That means, well, let's say this. If you're trying to do a division feature and you have no require, that's bad. Because what if I give you the divisor being 0? In that case, you might just crash without warning the clients. And if you have do over here and ensure. Also, if you have no ensure clause over here, that means anything will be guaranteed. Anything will be okay. Again, it's like ensuring true. However, if you really think that's really the case, you can leave them out, just like this. I would say typically you may not have precondition for your feature. You may not, sometimes. However, post condition you should always have to really define what's really the behavior of your feature. Okay? For lab number 1, I'm going to have you focus on the post condition. The precondition you will have to write for lab number 1 will be very trivial. But for the post condition, I do want you to think, especially mathematically. Okay? But we'll prepare you for that today. Okay, so that's about the feature over here. Okay, any questions? No? Are we okay? Good. Okay, so now what I want to do is I want to go over certain rules over here. Runtime monitoring of contracts. So before, the way we understand contracts are by thinking how the exceptions or how the assertions are going to fail or are going to occur. But now we're going to just clean it up. So we have no more exceptions, no more assertion, no more try and catch. Let's see how we can understand the behavior, okay? So now, first of all the contract you have, precondition, postcondition, invariants, they're all Boolean expressions. And Eiffel actually support the language for you to specify the Boolean condition just like how you did in 1090. So I'm also going to review some logical operators in Eiffel today. So it will help lab 1 a lot. Okay, let's just do something very quickly, just go over. Before you're trying to call a command or query or a feature, so what should you do? Remember we said before, you should really check for the inputs to see if they are satisfactory. In this case, we only check, so first of all, we call that a pre-state. Pre-state means before we try to execute a feature. There's another thing called post states. Post states means after we have executed the feature, pre and post. Okay? And then we have to check the precondition first before we execute the feature, right? That's how we understood. And then, this is interesting. I'm going to illustrate in just a moment. Let me go over the rule first. Somehow, there is some implicit cache of some attribute values that's done by the runtime of Eiffel Studio, which you don't have to worry about. However, when you specify the post condition, let's say for withdrawal, we say balance is equal to the old balance minus the amount. When we say old balance over there, old balance really refers to the value before we try to do the deduction, right? So somehow there's got to be a mechanism there to cache the value before the execution, so you can compare the two states, the pre-state and post-states. So now, for you to understand, there's some caching going on over there behind the scenes, okay? So whenever you use the old expression, and then, for example, you say old balance is assigned to balance. That's something that Eiffel Studio does for you, but you don't have to do it, okay? It's just there. Okay, so, and then we execute the body of the code and try to do some updates or do whatever you like. Now, what about after the feature call? According to your understanding, what should we check? How many things do we have to check after the feature call? Let's say we are done. How can we know that the contract has been satisfied? Positive balance. Let's talk a little bit more general term. Before the feature call, we check the precondition. What about after the feature call? Post condition and class invariant, exactly. So two things we gotta check, okay? Now, for the class invariant, in some ways easy, because the class invariant, which means now the resulting states from the feature execution, it must satisfy certain Boolean expression. I can just use the current values. However, for the post condition, as we will see, we will normally have to see draw a connection between. So now let me just show you very quickly. And then we can go on to the next one. Okay, let's just say a feature call. Let's say here, let's say this is certain states, and then we're trying to say withdraw, and some amount over here. Of course, it can be Allen, dot, and then we have this, okay? Let's explain the terminology very quickly. Before the execution is called pre-states. After the execution is called post-states. Okay? In the pre-states, there are two things, there only one thing we check, which is the precondition. Check precondition. Let's even make one concrete value, very just for illustration. Let's say in the pre-states, the balance is equal to 100. Okay, 100. Now, in the post-states, let's say the balance has been done, deducted properly, so it's now 90, right? You can see for the same attributes, we talk about two values, this and this, okay? So this 90 here is really the new balance. And this one here is really the old balance. And somehow Eiffel lets you refer to this particular attribute using the old keyword, okay? Old balance and new balance. So now, here is a precondition, okay? So now in the post state, we check two things. First of all, we check the class invariance. When we check the class invariance, we do not care about the old balance at all. We only care about the new balance over here. So we want to make sure 90 is still larger than 0, only the post value. However, for the post condition, that's the interesting bit. Post condition is usually the most difficult one to get right. So that's why we need to practice. For the post condition here, in principle, we are trying to draw a connection or relation between the pre-value and post value. In this case, we want to compare. You can see that we have old balance, which is 100, and also new balance, which is a 90. How can we draw a connection between them? We want to say the new balance is simply equal to the old balance minus the amount we're trying to withdraw, right? That's how we draw the connection. So that's a post condition. So that's how we draw the two things together. Any questions about how things are checked? Okay? Think about this issue here. So I kind of summarize the monitoring in one slide. Hopefully that's make it easier for you. Okay, so I will get to the violation in just moments, but I would like to just do something quickly just to see how we can see the violation. Okay. So let me just open Eiffel Studio. I will make the source code available to you, and for now I just want to use the one I have on the desktop. So let me say I want to use, okay, let me just go to eStudio, and I'll illustrate a few more points to show you. And then we talk about how you can test the contracts. Okay, so let's say, by the way, so sometimes if I say rather than creating a project from scratch, I might simply just give you some starter code, maybe some zip file. What you should have done is exactly what I did. If I, for example, if I give to you some zip file, what you're going to do is unzip it, so you will get like a project structure over here. So I'm going to open the project by using .ecf. If you have gone over the tutorial, ECF file is the configuration file for your projects. That's what you need to open the projects. Okay, so let me just go back there. So I would say rather than creating a new project from scratch, I'm going to say add projects, and then browse through there, BBC intro, and choose the ECF file. Do that and say OK. And then I can open. Take a little bit of time to compile. Okay. And of course, before you really decide to make a final delivery or submission, before you do that, don't try to finalize. It will take too much time, okay? Especially on the lab machines. Okay, it's done. So now, okay, it's over there. Okay, let me just tell you a few things that you should really pay attention to when you're doing Eiffel Studio. First of all, you want to know what's really available there for you to use. Like in Java, you will go to the online API to see if you have maybe string tokenizer, you have math, you have different classes. In Eiffel as well, you can do that. What you gotta do is go to, there's a class over here, and you gotta type the class you want to search. For lab number 1, there are 2 classes you have to search. First of all is array. So array is just a normal class in Eiffel. So I will leave, you can look it up and see what's going on there. Okay, that's one. And also you can see that there is certain, the resolution is not that great when I project, but on your computer you can see that there's certain panels you can look into. One is called groups, the other one is called features. Features is a little bit like the outline view in your Eclipse. So if you click on that, you can see these are all the features available under array. Okay, so now the other class you should really look into is linked list. And then if you refresh that, you'll see the features over here also tells you what features are available in the linked list, right? So that's what you gotta look up in the first lab. Okay. So now let me just go back and let's try to execute something over here. Okay. And if you want to look at in the current project what I have created, you should go under groups over here. It tells me that I have 2 clusters, bank and root. Okay, let me just, okay, that's better. I have 2 clusters. I got bank and I have root, these 2. And if I go under bank, it's an account. So account right now is exactly the class that I presented in the slides. Okay, so now you can see the syntax highlighting, etc. Now, I want to show you this. Let's say for withdraw feature over here, so you can see we are now declaring certain parameters. Let me talk about declaration in Eiffel. Okay. How do you declare variables in Eiffel? Let me just bring it back. Okay. Okay. The way you declare is slightly different from what you do in Java, slightly different. Okay. Over here, you have, in Java, for example, you would say integer I. That's how you do it. Now, in Eiffel, we kind of do it in a more mathematical way. Well, I'll show you why. So now, the way you would do it is, you're going to say I, colon, the type. In this case, every type is all capitals. That's how you do in Eiffel. Okay? So now you might be wondering, what's this colon here? It has a mathematical meaning. Remember this symbol here? In 1090 or 2090, that means it's a member of. We're saying that the capitalized integer there talks about a set of all possible integers that your computer can store. And then I is simply a member of that. Okay, that's how we declare. Okay, and similarly, you can also, yes?
Are the types in all caps because they're classes themselves, or?
Oh yeah, so there's a naming convention in Eiffel. So the convention is, whenever you're creating a new class or existing classes, it's all capitals.
Yeah, but like when it says integer, is it like an integer class?
There's an integer class. It's a little bit like a wrapper class in Eiffel, in Java. Yeah. Mm-hmm. Okay, that's something you can also explore during the lab, and then I can help you. Okay. Okay, let's now let's try to do this. Now, I want to show you how you can cause some runtime contra-violation over there. Let's say over here, let's have a look at this. I have withdraw command. You can see it's command because it doesn't return anything, right? Now, I'm saying it has one parameter, which is of type integer. You can see now I have two lines over here. This is one Boolean expression. This is just another Boolean expression, 1 and 2. So these are two separate preconditions I'm trying to define. Okay? And you can see that I can simply use a tag to actually give some meaningful description. And this is also very good for testing, as I will show you. I'm saying that I'm expecting the amount to be non-negative. That's a tag, like a description. And then the way I'm going to define that mathematically as a Boolean expression is say amount larger than or equal to 0. And the second one is the amount should be affordable. By the way, the tag name, the convention is all lower cases separated by underscore. Yeah? You mean the tag? Yeah, I would say the tag over there, it's a good practice to write a tag. As we'll see later, when you're trying to test your software, sometimes you want to test your software to see if they really actually cause the contra violation as expected. In this case, let's say if you have two different preconditions, you want to know which one really failed. In this case, you can see the tag names over there really distinguish. Okay? As you will see later, I'll convince you. Okay? But I would say if you just want to get some preconditions done and make sure you wouldn't mind cram everything together, you don't need it. But I would say for lab 1, you would need it. Yeah. And similarly, for the post condition as well. So here I'm saying the post condition I'm expecting is the balance has been deducted. And then I simply say balance is equal to O balance minus amount. Okay? Any questions so far? Okay. Let's see how we can cause a contra violation to occur. Let's see that very quickly. Every time you want to go to a new class, you can just double click and then open a new tab. Let's say I have one class over here. Okay. I'll just get there in just a moment. Okay, I'll just go to application over here. There's also a tricky point that you have to notice, okay? So a little bit like a Java. Let's say imagine in Eclipse, you can have more than one classes which has a main method. And every time if you want to run a particular main method, you're going to right click on that particular class and say run as Java application. In Eiffel, similar. I may have more than one classes as my entry point of execution. But every time before I do that, I need to change the project setting a little bit. I'll show you how you can do that, okay? Let's say now, I want to run some very simple console application just for the sake of illustration. I want to make this bank app as the entry point of execution. How do I do that? I'm going to set that as a root class, okay? The way I do that is I go to projects and go to project settings, okay? And go to target. So you can see there is something called root over here. That's the place where you're going to change. You can change from classes to classes. Currently, it tells me that it's referring to test suite, which is like an ESpec test, which I will talk about in just a moment. But now, let's say we just want to do normal console application. I can say account app, and then make. Okay, just say that. I'll just change that and say OK. Bank app, sorry about that. Project settings. Click on that. And I can say bank app. Just make sure you recompile after this. Okay, and then compile. Okay, I'll demonstrate one for you. Okay, let's say over here, let's just see the application class very closely. Let's say the first one. The first one over here, it's a make command over here. It's a command. It doesn't return anything. Make. And then you can see under creates, I declare make to be a constructor. Okay. And then over here, I'm declaring Alan as of type account. It's a local variable. And then I simply just trying to create. Okay. So this line over here is trying to create. I'll just talk about this quickly. Okay. It might seem very weird to you, right? But it's not too bad. This is how you create. I'll just compare very quickly between Eiffel and Java, and then you will see the difference. So how do we create objects in Eiffel? Object creation. Let's review what we have in Java very quickly. Let's say if I say account, Alan is assigned to new account. And then let's say Alan and then -10, for example. That's how you do in Java. All the critical information has to be included. For example, this type over here, and also information over here, and also the name of the variable. All the critical information should be there. Just the way we organize the syntax is going to be different in Eiffel. Okay, that's in Java. What about in Eiffel? Now in Eiffel, first of all, whenever you're using, so rather than using new, we're going to use the word creates. So that's a keyword. You're going to say creates. Okay, that means we're creating a new object. And now for the account over here, we're going to say create a type account objects. You're going to surround the type by curly brackets over here. And then the name of the variable is Alan. And then you're going to say dot the name of the constructor. In this case, make. Alan.make. And then the arguments over here. So it's not too bad. Basically, you include basically no more and no less information as before. Just the way you organize the syntax is different. Okay. You can also refer to the slides about comparing syntax. It's give you a little bit more insight into it. Okay. Let's go on. So now you can see that. Sorry about that. Let me just minimize that. Okay, so now we're creating Alan and then .make and then with a -10 Alan. So now, if we try to execute this code over here, we expect there will be certain precondition violation, right? Because that's -10. Let me just show you one, and then you can do the rest. So now, let me just let's predict what's going to happen. If you go back to the account class and go to make, you can see that we do have a required precondition there. You can see now, let's go back to your original question. Should we put a tag? It would be very useful because you can see the tag over here tells us if the new balance is not larger than equal to 0, we're going to get some precondition going to give us this tag to tell us which one has been violated. Okay, let's try to execute that code. Okay, it will simply say run. Okay, did some counter violation occurred? You can just say don't show again. Okay, it's to break simply means we're going to stop immediately. Okay, so now I will try to rearrange the window a little bit, but you also see the screenshot on the slides. First of all, you can see the error over here. That means something has gone wrong when we are trying to evaluate this particular precondition, okay, with this tag. And then you can see over here, this is something called a cost stack, which means we have some precondition violation over here with positive balance. So that's exactly the violation. Okay. So as you do lab number 1, I would expect you will run into this kind of situation quite often because sometimes you do expect the precondition violation to occur or post-condition, but sometimes you do not. So that's kind of the thing you should get used to. Any question just about this quick illustration here? Very quick. Okay. Let me point out one more thing, and then we can move on to how you can, and then I want to pause a little bit. I want to go over some syntax, and then we talk about how we can do tests in Eiffel Studio. Okay. Okay, let me just stop this somehow. One more thing to mention. I know it's a very frequent thing you will do. Let's say over here, let's say on my desktop, I know that I got this ifgen over here, right? I talk about ifgen, that's the generated code. Usually when I say you should really submit your project by deleting the ifgens because I don't want to include that. That's way too large. What you guys would tend to do, or your previous colleagues tend to do, they simply just delete the ifgens here right away before they close the Eiffel Studio. It's going to make it crash. I wouldn't try that here. I don't want to crash. But you can feel free to try that in the lab tomorrow or Wednesday and to see that really crash. You rather that crash it on Wednesday rather than doing the lab test, right? Okay, just to really make yourself learn a lesson first. Okay, good. I'm going to stop this, and then I want to show you one more thing. Okay. So now if I go back to application over here, you can see I'm trying different scenarios just like how we did in Java, right? I'm trying to create maybe Mark with $100, but I'm trying to do withdraw minus 1 million. And I'm trying to create Jim and then with 100 and try to withdraw 100, etc. You can see every one of them, I'm trying to list them in a different portion of the code. And I can just run them and then try to see if the expected contract violation will occur, like a precondition violation. Okay, that's how I expect to do it. However, what's the drawback of testing my code in this way? Like a console application, right? So if it works, it might print out something to the console, or it might just throw some contract violation on me, right? However, what's the drawback of this? What if I got 100 different scenarios over there? In that case, I would expect to see 100 different expected output versus actual output, right? And every time when I'm trying to compare if they match, it's by using my eyes to observe if the things really occur as expected. In this case, it's not very automated. It's not very good, okay? So it's pretty much like why you're using JUnits in 2030, because you want to automate the way you test your software. So we are doing something similar over here. There's just some syntax you gotta get used to. Okay. For now, let me just close this for now. Okay. Let me just go back to the slides. I want to go over some syntax with you quickly, and then we'll see how we can do test. Okay. Okay, Eiffel Syntax. I'll start from the beginning. If anything that I think I can skip, I'll just skip. Okay, I'll just write from the beginning. Okay, let me just go. Okay, escape sequences. Well, in Java, you say slash something. In Eiffel, just say percentage. That's easy. You can go over. This one is not difficult. I talked about commands, query, and features already, so that's one I can also skip. Naming convention also, right? Nothing too intelligent here. Okay, so now assignments versus equality. This is something that's very frequently confused, okay? So the way Eiffel define assignments versus equality is very different from how you do in the C family language. So in Java, you would say X is assigned to this value here, and it's not going to return anything. On the other hand, if you say X equals, that means we can compare and return some Boolean value, okay? Eiffel kind of goes back to, well, think about this. When you very first saw this symbol equal sign over here in your life, how did you interpret that? Was it for assignments or was it for equality? It should be for equality, right? The very first time you saw the equal sign, maybe back in elementary school, right? You didn't really learn the programming assignment to begin with. Very unlikely. So Eiffel here goes back to that kind of intuition. They said, if I say X equals 5 times Y, it means what it literally means mathematically. That means we are comparing the value, equal sign. So the next question is, what about assignments? Well, they just do colon equal assignment. Okay? That might be the most confusing part as a new programmer in Eiffel. Okay? Just pay attention to it. If you're really not convinced with the rationale I try to explain, just use it. Okay? Just syntax. Okay. What about declaring attributes? I said that already. So what you got to do is you're going to use the colon over here. That kind of means the membership operator. What about to declare a method or a feature? So let's say over here, the reason, let me just compare these two. Let's compare deposit and sum of. Just by looking at the declaration or the signature of these two things, I can tell this is actually a query. This is actually a command. Why? Because you can see that I have colon integer, which means it returns an integer, right? The return type. Okay. Again, we don't do the return type before that, like in Java, we do it afterwards. And if you have more than one parameter, you can just separate it by semicolon. Another thing you should really pay attention to, what if you have no parameters? Then what should you do? Let me close this. Okay, let me just write this down very quickly. So let's do another page here. Okay, so now let's say this. In Java, you might say void some method which takes no arguments, no parameter, do something here. What about in Eiffel? So you would do, first of all, you have a feature m, takes nothing, and then returns nothing. Do n. That's it. You can see no void and no empty pair of parentheses. Okay, that's something you should really pay attention to. So again, it's a very common source of error over here. So don't do that. Okay. Okay, now logical operators. I would like to review them very quickly. I do have also some slides to review each of the operators. I'll leave them to you to read. I wouldn't go over them in the class. The only one I want to talk about very quickly in class is the imprecation. Okay. Thank you. Forgot to swipe. Thank you so much. Okay, so now, let's first of all talk about logical operators. I'll tell you the whole story. Logical operators, we know that we have conjunction, we have disjunction, we have imprecation. So these are, and also we got negation. As you learn from 1090, we have the direct correspondence from Eiffel. We do. So for conjunction here, it's simply just and is a keyword, or implies and not. Okay, just spell it out. Okay. Well, it's a bit, again, it's a matter of style. I quite like that. It's pretty good. Okay, so now what about implies? Let's understand what implies really mean, because you will use implies quite a bit for lab number 1. Okay. First of all, what about we talk about truth table first, and then I'll try to give you some intuition. Okay, let's review. Maybe you have done maybe 1090 a long time ago, maybe. So remember, we talk about the operators. So it's a P implies Q. Okay, and over here, P and Q can have different combination, right? So it can be true, false, false. You know what? Let me just be a little bit more systematic. Exactly, thank you. That's exactly what I'm thinking. TT, TF, FT, FF. Okay? Now, before I fill in the table, let's not memorize, okay? This is how I remember it, okay? Again, the way to think about P implies Q is by thinking that as a contract. Think of it as a contract. Okay, so now I'm gonna put something here. So P implies Q is true if the contract is not broken, it's not breached. is not violated. Okay? Otherwise, if the contract is violated, it's going to be false. Okay, what about P and Q? For P over here, the way to understand this is P is obligation. Given certain obligation, and you get some certain benefits. Okay, let's say this. Let's make a contract. Let's say the P is like this. If you study 10 hours a day on 3311, that implies you're gonna get A+ in 3311. Okay, so P is, that's not necessarily the case, right? I'm just making one example. But I don't think it's gonna happen anyway. So let's say P is study 10 hours a day, not a week. A day on 3311, and Q is you will get A+. P and Q. So P is the obligation. And if you fulfill that, you're gonna get A+. That's the benefits. So now let's think about when the contract can be maybe violated. Okay? Let's think about a simple case. Let's say true in this case. For true and true, that means you really study 10 hours a day and you really get A+. And of course, that'll be great. The contract is respected. Like think about you study 10 hours a day, but you failed. That's a true-false case. In this case, the contract is not respected. In this case, false. What about false and true? This one might be the most confusing part. What does that mean? You didn't study 10 hours a day. In that case, does it really matter whether you get A+ or not? Doesn't really matter anymore because you didn't fulfill the obligation. So if you didn't fulfill the obligation, whether the benefits are really awarded doesn't matter. So that means the contract still was not violated, right? Just doesn't matter anymore. Okay, so now false. Similar idea. Again, the obligation was not fulfilled. Of course, there's no way you can violate that. You can see the only way you can violate the contract is when you fulfill the obligation, but the benefits were not awarded to you. That's the only case. Okay, so that's kind of intuition, right? Okay, and for conjunction, disjunction, and negation, they are very easy. So I'll leave that to you to study. And something I want to challenge your knowledge about Java, and to see anybody can answer me. It's an open question. Okay. Well, I know the answer, but maybe open to you. Let's talk about that. I think that's more interesting. You can look up the definition for other logical operator yourself. They are very straightforward. Now, as I said before, in Eiffel, you got this direct correspondence of conjunction, disjunction, implication, and negation. Now, I want to ask you this. In Java, first of all, do we have the implication operator? No. I agree with you, no. No such a thing. Negation? Yeah. Exclamation mark, right? Good, I agree with you. Now let's go to the real question. What about conjunction and disjunction? Do we have it or not? Yes. Well, I know what you're thinking. You're thinking this, right? Yeah. I can tell you that you are only about 60% correct. Not quite. Why? I give you a short answer to that and to see if anybody can really make sense out of it. So they are not quite the same because there's something called short circuit effects. Anybody actually heard about short circuit effect? It's not specific to Java. Actually got many C#, many other languages. Yeah, you heard about it, right? Good. Yeah. Okay. So because of the short circuit effect that makes short circuit effect, very briefly speaking, I will explain to you in just a moment. I think it's worth knowing. The short circuit effect makes the evaluation of ampersand, and vertical bar more efficient. However, mathematically speaking, For conjunction and disjunction, you should always evaluate both sides. You cannot say, I want to ignore one of the sides. Okay, let's think about what's short circuit effect very quickly. Short circuit effects. Let's say I got conjunction over here. Let's say I got expression 1, expression 2. Okay, what's short circuit effects? As we know, how can we make conjunction true? It's only when both sides are true. So now, short circuit effect goes like this. If I already know E1 is actually false, do I still have to bother to evaluate E2? I don't, okay? So now E2 is like a don't care. It's like a short circuit effect. Example, I'll give you one example right away. Let's say we are trying to access an array. We can say, I'll write it in another page. Short circuit effects. Let's say we have an array, integer A, okay, just Java, okay. We know that let's say we are trying to do AI, let's say I is certain integer. If you simply just pass any arbitrary I, for example, -1, you might get an index out of bound exception, right? How can we protect that? Short circuit effects. You can say 0 less than or equal to I, and I less than a.length, and this. You can see we got 3 parts of the conjunction. Part 1, part 2, and part 3. 3 parts. It's going to evaluate from left to right. As soon as we get any of the previous 2 conditions over here being false, it's not going to bother to evaluate this. So that's a short circuit effect, right? Maybe something you knew, but you didn't know it's called short circuit effects. And this short circuit effect makes the ampersand operator in Java there not quite the same as conjunction. No, they are not really the same. That's my point, okay? It might be just for your knowledge. So now, that's why in Eiffel there, you might find it interesting there. Eiffel, when you talk about conjunction there, okay, what about Eiffel? Eiffel support both version. So Eiffel over here, if I say and, if I say or, they are really logical. So conjunction, disjunction without the short circuit effect. What if you want something like an ampersand vertical bar? They got something like that. It's called and then or else. 2 keywords. So this is really equivalent to the ampersand in Java. This is equivalent to the vertical bar. So which one should you use? It depends. If in Eiffel you're trying to guard some array indexing, just like how we did in Java, use and then or else. Otherwise, you can just use the logical, in which case you're going to evaluate both sides. Doesn't matter which one will get false or true. Is it clear? The big picture, maybe? Okay, so everything, again, is on the slides. You can also go over. I just want to talk on the notes first. Okay, that's about logical operators. You can go over. And also, I review proposition, predicate logic, right? So you can go over that. Okay, obligation, benefits. And there's some theorems you might find interesting, also useful in the course too. Okay, I wouldn't mention them here. You can just talk, you can review them. One thing I would like to say, I will show you here. Something is about universal and existential quantification. Okay, you're going to use these 2 a lot in lab number 1, one of them or both of them. So I would suggest review these 2 concepts for all and exist carefully. I'm going to show you that you do have something that can simulate the for all and exist in Eiffel. I'll show you the syntax right away. Okay, in just a moment. Okay. You'll give you false. So, oh, it doesn't halt. I see. Oh, well, that means you got some problem with your code. So in this course, we don't really kind of deal with that. So basically, whenever you write any expression there, to evaluate that, it should terminate. It shouldn't loop forever. So here we actually will get it bounded. We will say, usually, well, good question. So I would, first of all, let me tell you the typical for all you will write in this course. Let me write it down. Remember what we did last time. When I say how you can express the array is sorted, right? Let me just write it down again. We're going to need that in just a moment. Since I talk about it, let me talk about it right away. Okay, so now math versus Eiffel. First of all, math. Let's say I want to say the array is sorted. Let's say array is sorted. Okay, like that. So now I'm going to say for every, let's say the A we talk about is really Eiffel array. Let's say array of integer. There are two useful attributes or features you can call. You can say something like a.lower and also a.upper. So a.lower simply means the lower bound for the array, for the indices. A.upper is like the upper bound. So in Eiffel, the array, the indices start with 1, not 0, 1. Okay, like a normal list. Okay, so now let's see how we can write this. I'm going to write it down over here. You'll say for every I, which is integer, such that now I should be bounded, not unbounded. So you will terminate. A.lower. Okay, let me write completely math, and then I will show you how Eiffel will look like, and then I will explain how what the Eiffel really means. A.lower less than or equal to I, less than or equal to a.upper. And then it is the case, right? ai less than or equal to a plus 1. And of course, you can see that when you have I plus 1, then you can have not equal over here, right? So let me correct that. Somehow that was intentional. Okay? Now that's math. This is, I would say, this is more or less the most common pattern you have to write. Might be slightly more complicated than that, might be, but more or less. Okay, let's see how you can do this in Eiffel. I also got slides for that, so you don't have to worry. But let me just try to explain right away. The way you do that is by using a syntax called across. Let me just put this into box. So how do we do this in Eiffel? Okay, so now we're gonna need to learn some new keyword here, across. Across is a keyword. Across, and then I'm gonna write down the skeleton first. Okay, 1, 2, 3, 4, 4 keywords. Okay, across, as, or, and. One thing you should really, first of all, I will tell you is, all over here can be replaced by some. And guess what? It simply corresponds to another quantification, existential, which means the sum value that satisfies the condition. Okay? So this simply means, sum simply corresponds to exists. Okay? So now let's see how we can do that. I'll write it down first. First of all, we have to give a range over here. I can say, I'll put a box over here. A.lower vertical bar dot is like a range, okay? And then it's going to go up to a.upper minus 1, agree? So I need to put a parenthesis to make the compiler happy. A.upper minus 1, okay? In some way, this range over here corresponds to this constraint over here, right? And of course, the syntax you got to learn is the vertical bar dot vertical bar. To the left, to the right, you can do any integer expression. It can be from 1 to 10. It can be from a.lower to a.upper, depending on what you need. Okay, we're almost done. And then over here, we can say as I. And this is the most confusing part. Okay, so now here's the thing. When I say I want to quantify over this particular interval here, For every particular value, I'm going to call that I. That's how you understand mathematically, right? But it's not quite there in Eiffel, okay? Let me go back to here in just 2 minutes. I want to explain to you how linked lists work before I can get here, okay? Let me just go back to the slides, and then I will go to linked list right away. Okay, this is like a conceptual view of a linked list. Okay, basically remember what if you learn back to your 2011 or 2030 or 2031, the way linked list works is you're going to have some dynamic structure and you have a cursor, right? So the cursor may be outside the boundary of the linked list, in which case if that's off the left boundary it's called before. If that's off the right boundary it's called after. If you're trying to run a loop, you're going to say I'm going to walk through the list until I'm going outside the boundary. Okay? And then the cursor over here, if you simply talk about the cursor and the way to get the element that's pointed to by the cursor, you're going to say dot item. Okay? Example. Let's have a look at this loop here, the lower part. You can see how we run the loop. So the way we run the loop in Eiffel, I got to explain the loop first, right? You can see it's like a stack. I'm going to explain to you all the prerequisites first. Let's talk about loop before I get back to your linked list. The loop, in Java, you got while loop or for loop. In Eiffel, only one case. But the way you define the loops is a little bit different. Okay, I want you to first of all look at this Java loop over here. So here you can see that, how do you interpret this Boolean condition? I call that the stay condition, stay, which means as long as this condition is true, I'm going to stay in the loop. But in Eiffel, it's going to be the opposite way. We're going to run the iteration until certain points that we should exit from the loop. That's kind of the logical negation of this you got to specify. Okay, so now let me show you how you can write it. So I say that, let's say I'll have a command over here. We have some local variable called I, the loop counter. So this is the structure of the loop. That's the most basic one you're going to write. You're going to say from. So the from over here is to initialize anything you want to initialize. For example, I can say initialize the loop counter to be 0. Now the until part. So that's the so-called exit condition, which means until this point here, I'm going to iterate. As soon as this exit condition becomes true, I'm going to exit. Okay? If you compare the Java and Eiffel, you'll see they're completely the logical negation of each other. And then every time you're going to make sure you say I is assigned to I+1. And by the way, I++, which you used to be able to do in Java, not in Eiffel, unfortunately. No, you cannot say that. Okay, that's about a loop. Let me go back to linked list very quickly. Now, how do you iterate through a linked list, which you will need later? So let me just talk about this here. So when I say, if I have a linked list variable, I say list.start, which means I'm going to make the cursor point to the first cell of the linked list. Okay? And then that's what you see over here, list.start. And then until, we're going to go from left to right, until the cursor is currently pointing to off the boundary on the right-hand side, right? Which is the after over here, right? We're going to start from here, go to right, go to right, go to right, until we are after, okay, from left to right. And then every time, if you want to move a little bit to the right, you can say forth, which means I go forth. And now here's the thing. Whenever you say the list over here is only the cursor to the list. So you want to get item that's being pointed to at, you're going to say list.item. Don't forget the item. Okay? Item will give you the element that's being pointed to at. Okay, given this, let's go back to my notes over here for a cross. Okay, so now over here, as I said before, over here when you have the I over here, again, let me just do some little bit more annotation for you. So this is basically a list of integers. Thank you, thank you, thank you. Can you see that? No? That's, okay. In that case, launch the QuickTime again. Okay, much better. Thank you. Yeah, you guys are well trained. Just remind me as soon as you don't see that. Good. Okay, so what I just wrote was this green part. I said the, excuse me. So now I say this part over here simply just give you a list of integers, okay? Like a linked list. So I is really just a cursor. So whenever you want to refer to the value that's being pointed to by I, you cannot just say I. You got to say I.item. So that's something you will certainly run into in lab number 1. But I'm pretty sure I'm going to answer you anyway. But please be reminded. Okay. So now for this part over here, how do we translate? Okay. The most frequent error is you might say A I less than or equal to A I plus 1. That's straightforward, I agree, but that's wrong. Remember, I is a cursor. It's not pointing to some integer. It's a cursor to some integer. To really get a value there, you gotta say this instead. I dot item. I dot item. I know it's very inconvenient, but hopefully I'm saving you like hours of struggling, I hope. Yes, plus, oh yeah, I'm just changing that I part to I dot item. That's what I did. No, you don't have to. Somehow the fourth is implicit for you. That's a good question. That's a good question. Mm-hmm. And by the way, this across syntax over here, well, I mean, if you really get used to it, the reason that I really want to explain this syntax in detail is I don't want you to struggle with the syntax too much for lab number 1. I really want you to write something that's very close to mathematics. That's my intention. Okay? Yes?
Do you mean that I is pointing to a space in memory, to a slot in memory, and then that's what contains item?
Yeah, so I over here, that's, yeah, exactly. So I over here, as I said, I over here is actually a cursor, right? Because we declare this range over here as a list of integers. I is simply a cursor pointing to it. Exactly, just a cursor. It's not a value itself. Yeah. Okay, any questions about this? Yeah. A dot upper minus 1. You mean over here? Yes, yes. Remember back in the math, we are trying to just do translation from math. I said before, it's going to be I is less than A dot upper, which means it will go up to and including A dot upper minus 1. That's why we put A dot upper minus 1 here. Let me give you one example. If you do, let me do another one. Across is really important. Okay, let's try another one. Let's do a little bit simpler. Across, let's say 1, 10 as I, and then I would say all. Underline means it's a keyword. All I dot item. So this is modulo, like a percentage sign in Java. 2 equals 0. So first of all, this is a Boolean expression. So what am I trying to say here? I'm trying to say I'm creating an intervals from 1 to 10 numbers. I'm going to iterate through them 10 times. Every time I'm going to check if I the item, if the value modulo 2 is equal to 0, which means if they're even or not. So do you think this Boolean expression will give me true or false? Good, very good. Because not all the integers in this interval are even, right? I can easily make this, so this is false. I can easily make this true by changing that to an existential quantification. In this case, that means there's at least one integer there that's positive, right? Even. In this case, that'll be true. Okay. Okay, guys, any questions about across before I move on? I think the number one thing, please, always say I.item. Okay? But hopefully once you get into the syntax here, you will somehow appreciate that Eiffel supports something that's very close to mathematics. Imagine how you would do this in Java. Yes? Oh, okay, no problem, no problem. Guys, let's understand something completely, all right? I'm glad you asked. Let's go back to this one here. I'm going to make some example for you. When I say, let's say we got an array over here. Let's say A. 0, 1, 2, 3, 4. You know what? Let's say there's Eiffel array. So the indices will start with 1. 1, 2, 3, 4, and 5. And let's say we got 3, 5, 5, 7, and 9. So it is sorted, right? How do we see that? Let's see math. What I wrote before, I said for every I integer such that 1 less than or equal to I less than or equal to 5. Let's put that here first, right? I used to say 5 minus 1. Let's just put 5 for now and let's see what's going to happen. Okay, we'll get there. And then it is the case A I less than or equal to A I plus 1, right? Okay, now let's see what's going to happen. So we know that I will be instantiated into 5 values, 1, 2, 3, 4, 5. When I is equal to 1, we're going to have A1 less than or equal to A2. In this case, we are comparing over here. 3 less than or equal to 5. That's correct. Next one, A2 less than or equal to A3. Indeed. 5 less than or equal to 5, right? Keep going on. What's going to be the last value for I in this case? 5. We're going to have A5 less than or equal to A6, but do we have 6 as a valid index? We don't, do we? That's why. So the last one, so here, you're really comparing like this, but here, you're going to go index out of bound exception. So that's why the last comparison you will do is this one here. So this one will be AI less than or equal to A I plus 1, but now you should really say 5 minus 1. Okay, that's why. Okay? Good. Brilliant. Okay, let's go back. Time really flies. Okay. I think I maybe talk about many important things. Let me just see, let me just go back. We talk about loops, that's really good. If statement is incredibly simple. Just no parentheses, basically. Okay? So you can also see the slides there. I talk about creating objects. I talk about constructor, that's good. Logical operator, oh, pretty good. One more thing I want to mention, arrays. So we talk about data structure, we got array. So now, how do you create an empty array? So that's kind of following our syntax here. It was a.makeEmpty. And one more thing I want to show you, that's also a little bit to do with mathematics. Okay. Yes, absolutely, absolutely. Okay, so now, let's say this. Let's say we have this array here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So this is A dot lower, this is A dot upper. So now, what's the size of this array? We know that's 6, but how do you calculate that? In general, if I give you upper, I give you lower, how would you infer the size? If I simply say A dot upper minus A dot lower, that wouldn't do. 6 minus 1 is 5, so it should be plus 1. Okay? Now, why do I mention about this formula? It's because if I say create some array A dot make empty, something you should really realize. Make empty, oh sorry, no this, not Java. Okay, let's say create empty. It's now empty. As we said before, the indices always start with 1. A dot lower is always equal to 1. Always. But now it's empty. What should be the upper? 1? Well, according to that formula, if A dot upper is 1, 1 minus 1 plus 1, 1, which is not empty. 0? Agree? So now there's a special condition you should really know. A dot upper in this case is really 0. Because 0 minus 1 plus 1, according to the formula, is going to give you 0. It's a special case, okay? Because Eiffel array allows the lower and upper to be arbitrary. Doesn't have to be 0 to be the lower. If you like, you can make the lower 10 if you like. But let's not do that. Okay, so I also talk about the across, right? Okay, I believe I cover pretty much everything on the syntax. Okay, go over that. And then if you got any more question about the syntax, you can ask me on Wednesday. Now I got 10 more minutes. What I really want to do is to show you how we can do tests in Eiffel Studio. Okay, I want to show you the process of doing that. Okay, let's do Eiffel Studio. That'll be the last topic for today. And now I'll go over some more points on the slides on Wednesday quickly. But now let's just do Eiffel Studio quickly. I'll show you right from the beginning. Okay, let's say I'm still using this. Okay, first of all, that's also on the slides. If you want to do a test, you want to use the testing framework in Eiffel. It's called ESpec, Eiffel specification. You can refer to the slides about the full name. So first of all, if you read the tutorial, if you want to add the library into it, you got to say project settings, and then you will see under groups, you can go to libraries, you can say right click and add library. And filter, you can type ESpec. And you can simply select that and say include. Okay, that's how you do. That's how you add a library. So now, but how do you write test cases? Okay, I'll show you how you can write it. So now, let me just add a new folder in my project there. I will call that tests. This is kind of the convention I will try to enforce from lab number 1. So we always got different cluster for different purposes. So you will always see a cluster called tests. We're going to get all the tests over there. Okay, I put the tests over here, and then I'm going to add a new cluster. Project settings. And then under groups, cluster, I'm going to add a new cluster. Add cluster, I'm going to call that tests. And location, remember from lab number 0, never ever put absolute path. Under the current project, dot, and then tests. Okay, like that. Okay, so now we do have a tests cluster. Let's create something very quickly. So now let's say new class. I can say, let's say test account. And I can say creates. I think I got one already. Let's say test account 2. Doesn't matter. Okay, it's a class. Now let me show you what you should do. Whenever you're doing this, I'm going to say, first of all, inherit from certain class. It's like in JUnit, you have to inherit from assertion. In here, we're going to say inherit ES Eiffel specification underscore test. That's what you got to do. Okay. So now, what else? I want to declare the constructor. So let's say creates, and the convention just make. Okay. And then I'm going to say feature. Remember, we can have as many features as you like, different sections. So here I can put some comments. I can say feature constructor for adding tests. Make over here, and then do end. Okay, one thing to show you. You can see now, since we got a feature over here, we can also get, I'll show you in just a moment. Okay, let's just focus on the test. Okay, so I will go over a little bit more theoretical details on Wednesday, but there are two kinds of tests you can write. Either you can say, I'm trying to use my program normally, and then I can compare the actual output against the expected output. That's one way. Or I can try to run my program in an abnormal way, which means I'm expecting some counter violation to occur. Okay, so there are two ways. I'm going to show you both. Okay, 5 minutes. Okay, test feature for testing normal run. And I got another feature here. So test, I may have more than one, test features for testing abnormal run. Okay, I'm gonna do the normal run first. And here is how we do it. For testing this first category, the feature has to be a query, okay? So here I can say test, let's say account with, let's say test valid withdrawal. Okay, and then it's gonna return a Boolean. Okay, just so it always has to return a Boolean. And then in the test, eventually you're gonna generate some test report. And it's required, you must have, if it's COM, okay, let me just compile first. Make sure everything compiles. Don't show again, yes. Yeah, the first time is gonna take a little bit longer, but it's getting there. Okay, good. So I'm gonna say comments. Okay, it's a feature that's supporting ES test, which means whatever description I put here is going to be included in the test report. Okay, I'm going to say test a normal run. Okay, it should be more meaningful, but it will do for now. And over here, I'm going to say, over here, let's declare a local variable. ACC, let's say Alan account, and then let's create Alan. Creates account Alan.make, right? Let's give a name. And then the balance, let's say that's usual, because we're trying to do some withdrawal. Let's say 100. Okay, getting there. And we're gonna say Alan.withdraw 10. Okay, so now how do I check it? So for queries in Eiffel, it's like like an accessor. You don't really return. There's no return statement in Eiffel. Instead, there is a reserved keyword called result. So the idea is you're going to keep changing this result value up to the point that right before the feature terminates, the final value for this result is going to be the return value for the query. Okay? So here I can say result is equal to Alan.balance is assigned to, let's say, not assigned, equal to, is equal to 100. After we initialize that to be 100, right? So you can see that this is a Boolean expression. We are trying to assign that to the intermediate return value. So this should be true, right? And then after this, I'm going to say result is assigned to Alan.balance. It is equal to 90. Very good. Okay, that's one test. So I'm only going to run this today. And then, so here, how do I add this test? So there are two kinds of tests I can add. I can say add Boolean case. Okay, so here's a little bit tricky. So this test feature here, think about in 2031, you learned about function pointer, right? So what you can do is you can pass a pointer to the Boolean query we just defined. And the way you can pass a pointer is by using a keyword called agent. Okay, and do that. And then, guys, just 1 more minute. I know I'm running out of time. Okay, I think what I would do is everything is on the slides. So on lab 1 on Wednesday, I will refer you to the particular the slide you should really study, and then you can just follow the instructions there to create a test. But in the lecture in the evening, I'm going to continue with this to explain more ideas, but hopefully that can help. Okay, I'll see you on Wednesday.